Hi, this is Adolph Oliver, and this is a video clip about scientific notation. Now, scientific notation is used a lot in biology, chemistry, and physics, and if you've had some classes in this, you've probably done some of this scientific notation already. It's designed to be able to multiply and divide very big and very small numbers. Now, what's important is there's a proper form that you must give the final answer in. And it's very important that you have this proper form. Here's how it goes. Okay, n times 10 to some power. Well, the n here is a decimal number which has just one non-zero digit in front of the decimal. Okay, and we're going to show you examples coming right up. So this is an important requirement. Remember again, to be correct, scientific notation must be written in proper form. Now, the m, the power of 10 here. This is one of the few cases where a negative exponent is allowed. But here's how it works. If this exponent is positive, then that means you have a large number. Now, what do I mean by large? Large compared to 1. If it's negative, okay, then you have a small number. And again, small compared to what? Well, it's smaller than 1. Now, here are 3 examples of numbers which are all the same numerically. They have the same total value. But there's only one of them that's in correct form. Not the first one. It's got a 0 digit out in front. We don't allow that. Not the third one. It's got more than 1 digit out in front. We don't allow that. The only one that's good here is the second one. It has 1 non-zero digit in front, so it is in proper form. Now, let's take a look at some examples to start with here. And here we go. First one of these. Remember, we said large numbers have a positive power of 10. Well, here we go. This is definitely a large number compared to 1. We want to write it in proper scientific notation form. Well, the first thing is we could put a decimal point at the end of it if we wanted. On a regular number. If it's a whole number, you can always do that. Where do we want to have the decimal point end up to be in proper scientific notation form? Right here between the 3 and the 2. So if we write this in scientific notation form, we're going to write 3.25. The rest of the trailing zeros you don't have to write. So 3.25 times 10. Now, this of course is a big number compared to 1, so we're going to have a positive exponent. The question is, what is it going to be? Well, how many places do we have to jump the decimal point? 1, 2, 3, 4. We had to jump it 5 places to get to where we wanted, so that means times 10 to the 5th. Well, small numbers have negative powers of 10. Here's an example right here. This is definitely less than 1. Okay, we're going to write this in proper scientific notation form. Now, where are we going to want that decimal point to end up? Between the 8 and the 3 right here. So we have 1 non-zero digit in front. So I could write this as 8.37. Here it comes. Times 10. Now remember, this is going to be a negative exponent. If it's positive, you normally don't write the plus, but negative you have to. How many places do we have to jump the decimal point? 1, 2, 3, 4 places. So that means this is 8.37 times 10 to the 4. Okay, well now, let's take a look at some examples on this, see what we can do here. Here are some that we want to convert to scientific notation, and again the requirements that they're in proper form. Once you see how this is done, it's simple to do. We start out with a large number, greater than 1 obviously, and that means the power of 10 is going to be positive. So here we go. Figure out where we want that decimal point to end up in our scientific notation form between the 4 and the 6 right here. So this would be 4.67. All the trailing zeros we can leave off. Okay, and now of course, how many places do we need to jump it? Well, of course, we could have started out with a decimal point at the end of the number, but where we want to end up with in scientific notation is up here. So times 10, we know it's going to be a positive exponent because this is a large number. Jump it. 1, 2, 3, 4, 5. We had to make 5 jumps, so 4.67 times 10 to the 5th. Okay, let's look at this guy. Now, by the way, look at this. We don't have to move the decimal point at all, do we? We've got one non-zero digit right out in front. So we can write it as 8.1 times 10. Okay, definitely a number bigger than 1 here, but we didn't have to jump the decimal point any places. So times 0 times 10 to the 0 because we didn't have to jump it. Now, if you write it in scientific notation form with a power of 10, this is what you'd have to write. Some people, since 10 to the 0 equals 1, will only say it's 8.1, but to be in proper form, here it is. Okay, well, a small number. Okay, well, again, since this is small compared to 1, we know it's going to have a negative exponent. Where we need to end up with the decimal point is between the 7 and the 6. So this will be 7.6 times 10. Now, since this is small compared to 1, we know the exponent's going to be negative. How many places we have to jump the decimal point? 1, 2, 3, 4 places. So 7.6 times 10 to the negative 4. Well, of course, the next thing we have to do is be able to take scientific notation and convert it back to regular numbers for us here. So here it is. Let's go ahead and do it. Now, we've got 3 examples here, all in scientific notation. What we need to do is write these back as regular decimal numbers. Okay, here's how you go about doing it. You see the 10 to the 4 here? This is a positive exponent, so it means this is going to be a bigger number. So I'm going to add some zeros here to see how many places we have to jump. Okay, and hopefully that's enough. If not, we'll add some more. We got to jump the decimal point 4 places, but we got to jump it in the direction to make this guy bigger. Well, okay, we got to jump it to the right. 1, 2, 3, 4. It's going to end up right there. So as a decimal number, this will be 685. Here we go. And we also have 2 zeros on it. Now, you could put the decimal point in if you want or leave it off. It's your choice. But again, since this was a positive exponent, that means we had to jump this decimal point 4 places, but jump it in the direction that made the number larger. Well, we have to jump it to the right. I added some zeros here. We jumped 4 places, and here we are. Now, the guy in the middle, 10 to the 0, we're not going to jump this, move the decimal point at all here. We jump it 0 places, so it stays right where it is. So this would be 5.7. Okay, our last example down here The exponent is negative, so that means this is going to be a smaller number. Okay, we know we have to jump the decimal point 6 places, but the direction to make this smaller, well, what I'm going to do is add a bunch of zeros out here in front. Let's see if that's enough to be able to do this. And so here we go. It's going to be, let's see, we got to jump it 6 places. So here we go. 1, 2, 3, 4, 5, 6. Hey, I just made it. So the value is going to be decimal point. I'm going to have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. And then the 2304. 2304. So there's the actual decimal value. Now you could take that and convert it back to this scientific notation, and this would be what it equaled right here. But remember, in this page, we were getting practice converting scientific notation back to regular decimal values.